Hello everyone, Assalamualaikum warahmatullahi wabarakatuh, and good day to every one of you. Welcome to my video. So in this video we are going to continue our discussion for chapter on transformer. Okay, and then this video we are going to continue our discussion on the subtopics of the practical transformer and also the equivalent circuit parameter for the practical transformer. Okay, alright, so let's go to the first subtopic, which is the practical transformer. So what is the difference between the practical transformer versus the ideal transformer that we have been learned in the previous video? So basically in the real world, the transformer are not ideal. Okay, the practical transformer has the following characteristic where the ion core will produce eddy current and hysteresis losses, which contribute to the temperature rise of the transformer. And then next, the core is not infinitely permeable. If you still remember, for the ideal transformer, we consider the core has a infinite permeable, but basically for the practical transformer, the core is not infinitely permeable. Okay, and then the winding has a resistance. Next, there is a reflux leakage, meaning that the flux that produced by the primary is not completely captured by the secondary. So unlike the ideal transformer, we consider that all flux are confined in the core and then will be linked between the primary winding and the secondary winding. But for the practical transformer, the flux produced by the primary will not be completely captured by the secondary winding. Okay, so now here is the schematic diagram for the practical transformer. Okay, so where the winding resistance, here is the winding resistance. The flux leakage, here is the flux leakage. And then the core loss are considered. So this is represent the core loss. Okay, so when we consider all the three, you can draw your practical transformer just like this, where you have a primary winding. Okay, the primary winding have a internal winding resistance, and then the secondary winding also have a internal secondary winding R2. Okay, so basically we can redraw the schematic diagram into here. Okay, where you have a R1 and XL1 connected to the parallel of RC1 plus XM1. Okay, so this is due to the excitation of the core. Okay, so usually the IM is required to establish the flux in the core, and then the effect of the IM is represented by the XM, and then the RC is due to the core loss. Okay, because we consider the core loss, so that's why you have RC1 and XM1 here. The R1 and R2 represent the primary and secondary resistance of the winding. Okay, and then the XL1 and XL2 represent the primary and secondary leakage flux. Okay, so here is your primary winding, and then the next one is the secondary winding, and then the parallel bar represent the mutual flux between those winding. Okay, alright. So this is the equivalent circuit for the practical transformer, where your V1 represent the primary voltage, okay, I1 represent the primary current, N1 represent the number of turns at the primary, E1 represent the primary induced voltage due to the N1 and I1. Okay, alright, and then V2 is the secondary voltage, I2 is the secondary current, N2 is the number of turns at the secondary winding, and E2 represent the secondary induced voltage due to N2 multiplied with I2. Alright? And then for the impedance transfer, when you transfer your circuit from secondary to the primary, okay, here referred to primary, so this is the equivalent circuit. Okay, so you don't have the transformer winding anymore. Okay, and then you just transfer your R2, XL2, E2, I2 and V2 to the primary side. So that's why here you have XL2 prime, R2 prime, V2 prime and E2 prime here. Alright. Okay, so basically this is the general equation for the transformer. Okay, so based on the general equation, you can come up with the equation on how to find the value of E2 prime, I2 prime and V2 prime. Okay, so if you refer to here, in this case, once we convert our circuit from here to here, you know that E1 will be equal to E2 prime. Okay, so E1 will be equal to A multiplied with E2. So A multiplied with E2. So for the V2 prime will be equal to V1. Okay, so V2 prime is a V2 multiplied with A. Okay, A multiplied with V2. For I2 prime, because I2 prime will refer to the primary side. So I2 prime equal to I1. So I1 will be equal to I2 divided by A. So I2 divided by A. Okay. So for the value of R2 prime and XL2 prime, we can refer to the equation of the impedance that transferred from secondary to the primary. You know that Z2 prime is equal to A squared Z2. So that's why if you want to find the value of R2 prime, will be equal to A squared R2. Okay, and then for the XL prime will be equal to A squared multiplied with XL. Okay, alright. So this is how you convert from your ideal transformer circuit to the equivalent circuit that referred to the primary side. And then next, for the equivalent circuit that referred to the secondary side, so next, the equivalent circuit of the practical transformer can also be represented by this circuit, where in this case, you refer your primary side to the secondary side. Okay, so that's why here you have V1 prime, R1 prime, X1 prime, I1 prime, and RC1 prime, XM1I prime. And then also you have E1 prime, because now in this case, you refer your primary side to the secondary side. Okay, and then the value at the secondary side remain. You have X2, R2, V2, and E2. Alright, okay. So how to get all this value? You can just refer to the general equation of the transformer. Okay, so based on the general equation, you can come out with this equation. In this case, E2 will be equal to E1 prime. So E2 will be equal to E1 divided by A. So here E1 divided by A. For the V1 prime, because you refer V1 prime to the secondary side, so equal to V2. So in this case, V1 divided by A. V1 divided by A. Okay. And then for the I1 prime. So I1 prime will be, you refer to the secondary side. Okay. Sorry, I1, you refer to the secondary side. So that's why I1 prime is equal to I2. So I equal to A multiplied with I1. A multiplied with I1. Okay, and then based on the equation on the impedance that you transfer from the secondary to the primary. So based on this, you know that Z1 prime equal to Z1 divided by A squared. So that's why in this case, R1 prime will be equal to R1 divided by A squared. R1 divided by A squared. And then for the X1 prime, or you can also call it XL1 prime equal to XL1 divided by A squared. Divided by A squared. Alright? Okay. So this is how you get the value of the equivalent circuit that transferred from the primary to the secondary. Okay? Okay, so now in this slide, it shows you the example of the equivalent circuit that refer to the primary side. Okay, so all the value at the secondary side, now you refer to the primary side. So that's why you have X2 prime, R2 prime, I2 prime, and V2 prime. Okay, and then the excitation branch here has a very small current compared to the load current of the transformer. Okay, so the value of IM and IC1 here is very small compared to the I1. Okay, so you can simply move this one to the front. Okay, so you can get this. So now you move here to the front so that you get this kind of circuit. Alright, so based on this, you know that your Z equivalent will be equal to R equivalent plus X equivalent. Okay, and then your total equivalent resistance will be R1 plus R2 prime. Okay, you can just simply add on R1 plus R2 prime because you already moved the excitation branch to the front. Okay, now in this case you have R equivalent equal to R1 plus R2 prime. Okay, and then for the total equivalent of the reactance, you have X equivalent equal to X1 plus X2 prime. Okay. Okay, so now you had learned on how to get the equivalent circuit of the practical transformer, and then you should know on how to refer the circuit either to the primary side or to the secondary side. Okay, and then in the next video we will see on how to determine each of the parameter of the transformer. Okay, so we will see on how to determine the value of R1, X1, the value of RC1, XM1, R2 prime, X2 prime, and so on. Okay, so we will see in details on process to determining all the parameter in the next video. Okay, so I think that's all for now. Thank you for watching my video. Thank you for your time. I'll see you in my next video. Okay, bye.